in bridges. Okay, as per IRC loading, why you have to do the IRC recommendations? Like for what are the things related to the transportation, related to the road construction. Okay, in between the road only bridge is connected, right? Okay, so follow the Indian Road Congress recommendations guidelines only. If you go for the construction of any other structure apart from the roads, apart from the transportational structure, then you can methods like reinforced concrete L1 methods are there. Okay, by using the IS 456 2000, you can design the structure and you can construct the structure also. It is this structure is related to the transportation. We go for the IOC road recommendation design. We have completed the design also in the previous class. Okay, so this class, what are you going to do? Drafting in AutoCAD. Okay, you have learned some of the new commands in the AutoCAD in the previous classes, and I'm going to specify. I'm going to show you additional commands. Okay, it will help you for the quicker completion of the drafting in the software. Share the AutoCAD screen so that we'll start the drafting process. Can you all able to see the screen? Can you all able to see the screen?
Yes,
Okay.
sir.
So now, now we're going to draw. As soon as you open the AutoCAD software, what you should do, you should set the limits first. Okay, so limits is in the sense LI. This is the, if you type limits and enter, so then you can set the limit. First is you have to set the one corner limit, that is 0, 0. Then the upper corner limit. Upper corner limit is your choice. You can go for 1000 or 10,000. So I'm fixing 1000. Comma you have to type. So that limits is fixed. Okay. So after that you have to set the units you have to type. Then you enter. So this dialog box will come. You set the precision. Then you set the units. Okay, so it is in millimeter, so we're going to draw in millimeter only, so we'll draw the drawings in millimeters. Okay, so click on OK, so that the unit also to draft the solid slab first. Okay, so dimension of the draft solid slab has to be drafted first, then you can go for the reinforcement detailing, and then you can provide the supports that particular bridge. Okay, so first of all, clear span is 9 meters actually, 9 meters. Then the carriageway is 7.5 meter, and the footpath is 1.5. Altogether, the clear span is the span of the bridge is 9 meters. So you just type L, enter, so that line command is activated, and you give that. So in millimeters you're going to draw, so that 9,000 millimeter. Escape. You just click the escape, so that you come out of the. So I'm just moving this UCS icon. Okay. Okay. So the icon is moved. So now we can proceed the drawing. So the baseline of the, then you have to consider the overall depth of the solid slab. So okay, the overall depth of the solid slab is 675 mm. Okay, so that is the overall depth of the solid slab. You just offset. Shortcut for the offsetting any object. Oh, enter. Then you have to specify the distance. Okay, so the distance is what? 7.5. You just enter the value and just. So then you can choose the source value. So it is offsetted. Hmm? Now you can connect this two line. Of the solid slab is over. So with respect to the span, with respect to the overall depth, we have created the outer solid slab. Then you have to go for the reinforcement detailing. So reinforcement detailing, so this is the coverage. Okay, this is the outer cover of the solid slab. Then will be provided, right? Okay, so based upon the clear cover, the reinforcement is provided, so that the clear cover of this particular solid slab is 30 millimeters. Okay, so then you have to off 30 millimeters distance. Okay, you just click O and enter. Then the distance is 30. Okay, so also 30 you enter. Then you can create the reinforcement detailing. Okay, so the main reinforcement, if you cut the, so now we are drafting the long. If you cut the solid slab longitudinally, that is along the lengthwise direction. If you cut and see from the front view, the appearance will be like. Now what you should do, you have to trim the unwanted portions here. Why? Because so the bars will not be provided like this. Okay, so that this portion and this portion should be a trimming. What you should do, I'll tell. Okay. TR you enter and double enter you have to do. Okay. One time enter and the second time enter. So that the trim of these portions. What we should do, now you should provide the hook of the main reinforcement at the top as well as at the top as well as at the bottom. So like this bar is there, no, so this bar dimension you just check once. So how to check? Click on linear dimension so that you can check the dimension. So from the top to bottom it is 615 millimeters. Okay, so up to 500 millimeters of the 115 millimeter at the bottom, so that it act as a hook to the top reinforcement bar. Okay, so how can you create? You can click the you can create some reference line here. Okay, just click 115 so that some reference line is created, so that you can trim the bottom portion. TR double enter. Okay, so therefore the hook is created. Similarly, you do it on the other side also. So how will you do the same procedure? Line enter, then 115 enter. It will be like the delete this one. TR double enter. So you're going to trim. Then you can. So thereby you created the hook hook from the for the top reinforcement. Similarly, the hook of the bottom reinforcement No, so for that also you can have the reference line concept. Okay, so line enter. So the diameter of the bar is 25 mm, so that you can have the 50 mm from this line. So 50 mm. So from this point, so you can have the 500 mm enter. So the value is 500. Therefore, the line is created. Okay, so this is the hook length. Similarly, you do on this way. Therefore, the main reinforcement rafting has been completed as of now. Now you're going to do the distribution reinforcement detailing. So for that you should consider the shear force and bending moment condition in this particular solid slab of the bridge. Okay, so what is the shear force? It will be maximum at the corners and it will be minimum at the centers. Almost you can say at the midpoint of the simply supported structure, the shear force. So the shear force intensity is maximum intensity at the corner and minimum intensity at the edges. At the maximum intensity at the corner and minimum intensity at the done. Okay. So after that, if you consider the bending moment intensity is as vice versa of shear force. Okay. It will be minimum at the corner and maximum at the support. So therefore, reinforcement distribution reinforcement will take care of the shear force. Take care of the shear force forward probably. Okay. So therefore, the number of shear force, the space corners will be less. Okay, the spacing between the distribution bar at the midspan will be more. Okay, so that is the thing. So now we're going to see the distribution for the distribution bar along the longitudinal direction. You can see as a dots only. So I will see as a dots. Before that, what you should do, so you should this is the overall. It is 9 meters. Okay, so you have to split this line. So you just delete this line as of now. So then click on line. Okay, so it starts from the year. The first corner foot part ends at 1500 mm. So therefore 1500 mm. You just click on enter. So after that the carriageway it is 7500 mm. Okay, so the carriageway is created again. Sorry, again you have to click on the line. So from this you click the another 1000. So the bridge ends at this particular position. Okay, so after that you can close this 675. So again you just join the line here. So this is the way the bridge is going to be. So I'm just changing the this drawing. Okay. So why? Because you have to provide the footways on the both the direction. Again, you have to create the hook also. Okay, so that is the thing you should do. Why? Because to provide the footprint, the process is same. Okay, so why the what is the process? So you create the line. So 115 meter from the bottom, 115 millimeter line. So you just delete this one, trim this one, again you delete. Then go for the line option. 500 is the hook length. So you just trim this, delete this one. Now you can proceed our now it has been differentiated. Okay, so this first line is one corner footway. The second line is carriageway length, and this third line is the another corner footway. Okay, so now you can draw. So from the 0 to 1500 mm, so the distribution reinforcement is congested. Okay, so the distribution reinforcement. So that's why we do that. Okay. Okay. So for drawing the distribution given as a donut only. So DO enter. So you specify the inner dimension, that is 0. Inner dimension is 0. So outer dimension is what? So that the donut is created here. Okay, like this. It doesn't have any inner dimension. So the reinforcement bar is created, so that you just right click and copy, or else you can move also. You can move this particular so you have to off the ortho, so that you can the angular direction. Okay, so you just place here. Okay, now what you can do, so this command I'm going to tell now is new to you. You just have a note. Okay, so you just have a note with for this command. So from the corner, so from the corner, you're going to use the array command. Okay, so how will you use the array command? So that I'll show you now. Before that, you just delete this icon line. First 1500 only. So the cover is reduced to 30. So actually, the first footpath is 1500 meter. Now the cover you have to subtract the 30. So that the final carriageway width, considering the reinforcement aspect, it is okay. So that is the reinforcement width. So then you can go for the array command. How can you go for the array command? So you just copy this and array. You just click type array arr. It will be created. So it is angular or path. Rectangular means it will be created in the rectangular way. If you see here, it will be created like this. Okay. So we are not. We need to use this rectangular array. So that what I'll do. So I'll just delete this one. And donut again. So donut is nothing but the distribution reinforcement. It will be shown as a. So you just place this one. So right click array. So path array only you're going to choose. Okay, path array. So you choose the path. This is the path. The bar has been created like that. But we need not to use this for use this drafting. Why? Because there is no space in between the. As per the design specification, you have to 25 diapers that you have provided correctly. At 280 spacing, you have to provide. Okay, so you have to provide at the uh, at the top. Okay, so how can you achieve the 280 spaces between this? So you just right click this one. So right click this one. Quick will appear. So if you see here, the item spacing is 19. It is not enough. So you need the 180 spacing. So you just change the item spacing and you click on enter. So that it has been spacing has been changed here. Okay. So again you draw the line. Okay. So what is the line? Line command L enter. So you click here. So it is 7,500. That is the mid carriageway length. Okay. So the 7,500 is created. Again, what you should do. Draw some reference line. Okay, so what is the reference line you should draw? Why you should draw? So because there will be place the donut here. Okay, so what you should do? You just have the reference line. Line enter. What is the next spacing? The next spacing actually from the starting 0 to 1500 millimeter, the design specification is 25 dia bars at 280 spacing. Okay, to another that mid carriageway. So use only 10 dia bars at 250 spacing. Okay, so 10 dia bars at 250 spacing. So debo enter. Again internal dimension is 0. Yeah, outer dimension is 10. So that you just have the donut. Okay, so that the 10 dia donut is created. Actually 10 dia donut. This is 10 dia donut. Okay. So what is the spacing? So the spacing is 250. The spacing between this rod and the next rod should be 250. So that line offset O enter. Offset distance is 250. You just click again. So like this you draw. So this is the reference line you are drawn. You can delete this one. The donut newly created donut here. Okay. So move. So you have placed the donut, then you delete the reference line. So now you repeat the array command here. Picture itself we can observe. Okay, so this is big and this is small, 25 mm and 10 mm dia bar. Okay, so at the end you go for the can you all able to see the screen? So someone has entered the got disturbed. Can you all able to see the screen? Yes, answer me. Can you all able to see the
Yes,
screen
sir.
or not? Yeah. So now by here. Okay, so what is the mid span? That is the carriageway distribution design specification is 10 mm diabars 250 mm spacing. Okay, so you have created the 10 mm diabars as a to use the array command again to the path only. So you create the path. So the this has been created. Again, you have to select this one. Select this one and click on quick property. So the item spacing is 8. That is not enough. Then you have to go for the 250 mm spacing. So 250 you enter at the item spacing so that the spacing will be changed. Okay. Then you have to delete this one. So you have to delete this one. How will you do? Okay, we can extend for the next footprint. Okay, so this reinforcement be there. So the same reinforcement detailing to be repeated again, so that you can select this. We select this CO, enter. So we are created like this. Okay, so the as per the requirement, okay, design requirement we are created. Okay, so this one is why because the reinforcement given here, okay, for the distribution is big. Why? Because the shear intensity is maximum. Then you have provided the mid reinforcement. Okay, so that reinforcement is for the carriageway. Again, you have provided the this reinforcement. That is nothing but part on the other side. Okay, so now what are you going to do? So you're going to repeat the same thing here. Okay, so how are you going to repeat, so you just click on donut, enter. So the internal dimension is 0 and the external dimension is 25. Okay, so that it is created. Again, just copy this one, so place it here. So that you delete this line. Actually, now if you see, already 50 mm is gone. Okay, so from here to here, it is like only line command, L enter. It is from the 1500 footprint is 1500, but you have to subtract it for the clear cover as well as for the hook length. So therefore, it is 1450 only. Okay, so 1450. Escape. You just click on the escape icon. So after that, you just click this one, and again the same array ARR AY. So path only. So you just click the path. Again, you just right click this one. Quick properties. The spacing between the two paths at the bottom is 25 at a 280 mm spacing. So therefore, the spacing is 380. So that you achieve the spacing. Okay. So the same thing as to repeat. So line that mid distance is what? So the mid distance is 1500. 1500. Not 1500. 7500. So it is created like this. So you draw the reference line, or else you can do one thing. So the same, yeah. Donut icon. So 10 mm diabars. Use the same center. Okay. So now again you have to create the downward reinforcement detailing for the carriageway. Okay. So the same array command you can array. So that is for array. Along the path, you click the path. Okay. So again you go for the quick property. Item spacing is 250. You have to click the number of items is 30. Okay. Then uh, the next side footpath is there. No, so that footpath reinforcement you have to do. Okay, so you just have the copy CO and enter. So you just copy the same element to the next side. You can trim this one. We have created, actually we have created the main reinforcement as well as the distribution reinforcement for the solid slab of the bridge, which has been designed as per the recommendations. Okay, so we are given the reinforcement detailing. So next what you should do, so you should provide the crank. So what is the crank you so if you see here transition, so from the 25 it transited to 15, so that this portion has to be cranked to taken care of the shear. Okay, so like a separation only. So just click on the this place like this. Like this, the crank will be provided. Okay. Similarly, the crank on the other side direction. So this so this is the way. This is the place where the transition is happening. Okay. So that you just click on the line command on the center of this transition, and you just connect this one. Even you should. This is the crank, okay, which separates the carriageway. Okay, so behind this line it is a carriageway. Similarly, behind this line it is a carriageway. So the mid is for the footpath. Okay, as well as the behind this line it is a footpath. The mid path is a carriageway where it has been utilized for the transportation purpose. And here the it can be non-vehicle usage persons. Okay, so they can walk on this path. Okay, so this is the holistic appearance. Okay, reinforcement detailing. Actually drafting has been completed. Okay, so now we're going to detail. So I want to cover you one thing. So what is the thing? If you see, we have seen different types of beam. Okay, so based upon the support we can classify the different type of beam. The simply supported and cantilever, then overhanging and continuous, like this. Based upon the support it has been classified. So if of a beam you will choose, so you will choose the simply supported kind of beam. Okay, why? Because the fixed beam, so if it is fixed, the rotation in that particular beam will be restricted. Okay, it should not be there. Okay, so if you restrict the rotation in the bridge, then the bridge will be collapsed. Therefore you go for the simply support type of simply support in case of bridge. How the bridge will appear, so we have designed the solid slab. So you anywhere. Okay, so how can you give the support, so the bridge has been supported by the abutments on the both the sides. Abutment means it is made up of the cantilever. It is like a support. Okay, so simply the solid slab, that is the solid slab of the bridge will abutment with some connectivity with the bridge deck. That is the T beam that we'll see afterwards. Okay, so the bridge is supported by the abutments on the both the directions, and it has been supported by the PS. Okay, so PS at the mid spans. Okay, so abutments at the both the direction and PS at the mid span. Now what we going to continuous bridge actually. Okay, so at one side there will be abutment, on the other side there will be a pier. Okay, so as I told already, it can be the continuous thing. Okay, so like what we going to create the abutment now. So what is the abutment? So it is made up of a cantilever wall. I have told already. We have designed and drafted the cantilever wall in the previous classes. Okay, so now you just so that you create the abutment. Okay, so in this side you are decided to have the abutment. Okay, so it can have some 100 mm. Same as here. Now it's 50 mm. It can be somewhat like 5 meters. So you can have the height like this. Then the support width can be not 1,500, so that can be the support width. So you support here. Yeah, you can consider as abutment. So for cut section, you have to create this as a cut section only. So line, enter. So this is the cut section which shows the indication of bridge. Okay, so you can have the extension like this. You have decided the one segment of the slab in the bridge only. But if you see the actual bridge, it is made up of several segments. Okay. So again, what you're going to do, so on this, in this, it is supported by the pier. Then you see the you just fix the continuation link afterwards. Okay. So you just create the pier. So for that. So the most frequently used command in the AutoCAD, so that is the line only. Line command 500. You just click the you just check the dimension once here. Hundred is a big dimension, so that you can go for lesser dimension. Or else you do one thing. You just copy this one. Approximate dimensions only. Okay, so that you can create on your own. This is the way you can create the pier. Okay, so this edge is there. No, you decide to have the sharp edge here. Okay, so you decide to have the sharp edge. It's a particular sharp, so that I will show now. Okay, so for that you can have the modify command. Okay, so that you can have that one. Just create the line. So choose the mid span like this. So the base can be the same. The same base you can choose. Line command. So this can be considered as a reference line. Okay, so you have to trim this one. Yeah, double enter. Then you delete the reference line, so that from the midspan you just create the peer width. Okay, so what is the peer width? 100 or 200 Okay, so you can go for the 200 So therefore, from the from the center, you have to offset 100 enter and 100, so that you can delete this reference line. Again, you can choose the line command. Enter here. So choose the midspan so that you draw the cut section. So when I'm no, so why? Because the commands are given in the previous steps itself. Okay, so that's why I am not instructing. I'm just drawing. Okay, so if you have in that time, I can show. So what is the new command I'm doing now? That time I can instruct what is the new command I am doing that time. Okay. The almost we have completed the drafting. Okay, so as I told already, this is not the complete bridge. You have to show the continuation to the next extent. Okay, so how will you show the continuation? So this show that is this is this yes, this particular session is continuing and it is not ended like that. Okay, so for that joint filler, I want to tell about the joint fillers. Joint filler is nothing but the construction joint, like a construction joint. It will be provided in between the two slabs. Why? Because to give as well as the contraction of the solid slab due to loading. Okay, so that you have to create. Okay, so how will you create? So just same thing. Line enter. You just click on here and the thickness of the that particular edge. Okay, so then you just close this one. Now what you're going to do? Here double enter. Again you draw line so that it will be the separate element. Okay, so now you're going to hatch. Okay, so the material you're going to use it here is solid. Okay, so HATCH command is new. Okay, hatching is you're going to fill the space with some indications. Okay, HATCH enter. Okay, so so picking the internal points like that, so that you can change the. Okay, there are different patterns. If you see, can you all able to see the pattern here? Can you all able to see the pattern here?
Yes, sir.
Yes, sir. Yes, sir.
See or not?
Yes,
At the
sir.
left side corner. Yeah. So among this pattern, you can choose the steel. Why? Because the the joint going to be provided with the steel material. Okay, so so it is very closely packed, right? You change the scale. Okay, so you just select the hatch materials which is filled and SC. So that is the um, for the scale. So SC enter. Okay, so select the base point and what is the factor you're going to do. Okay, so what is the factor you're going to do? So you're going to have 1.5 means properties. You can go into a 1.5. so that it is visible. Somewhat it can be visible. Okay, even though it is not also. Okay, so this is the steel material. Okay, so this is the representation of the steel material. Again, you go for the extension. Extension of this particular slab. Okay, so what you'll do, you know, so you go for the adjacent span. Okay, so adjacent span, how will you create? Line, enter 500 or 2000. So you create the cut section here. So this is the mid span. So this is the construction which shows the bridge is not ended, it is continuing. Okay. This we are completing the drafting process. Okay, so we are drafted the bridge completely. Okay, so what are the things you should do? You know. So the some of the ins. Okay, so key points related to the bridge. Okay, so the first thing is the bridge is supported at the corners. It is supported by the abutments. Okay, so that we are mids. It has been piers. Okay, so below the pier, what will be there? So pile type of foundation will be there. Like three group file or four group file depends upon the pile will be designed above the pile. So collectively for the four group file or whatever may be the group of file, so you will have one pier, one single column. So that is called pier. So slab of the bridge will be supported like this. One end abutment and the other end pier. Okay, like that. Okay. So, but if you consider this is the first span, the bridge will have several span solid slab. Okay, so this is the first span is there. No, likewise it will be repeated like this. Okay, so for example, it will be repeated like this. Again, the pier will be continued. So at the end, they will provide the apartment. Okay, so this is the thing. So we drafted the bridge. Now we're going to go for the detailing. Okay, so what is the detailing for process? How will you do the detailing for process? You know that you are done in the previous class already. There is no change in the command which you're going to use. Change, you know, so you have to practice that one. So that is the thing. Okay, so I'll go for the M leader. MLEADER. So that is the options you have. So you just click on this particular reinforcement or the main reinforcement also. In style, you know, so in annotation you can change. Uh, you can go for 100 mm. So that can be that can be. Okay. So the first reinforcement detailing, that is the main bar reinforcement detailing is what 25 mm. No. So the main reinforcement at the 280 mm spacing. So 10 mm bar 280 center to center. So do you want to change text? You can have. So I'll repeat the steps again. So this has been created. 10 mm dia bus. Further reinforcement detailing. This crank bar is there, no? So that for that. So what is the detailing, you know? So the detailing will be 25 mm dia bus at 280 mm spacing. Again, this mid span. So mid span and all 10 mm dia bus at 250 mm spacing. So this is a joint that you should detail. Giant filler is nothing but in between the two span of the solid bridge, you know. So the giant is provided. So that is called giant. So giant filler. So after that, you can have the detailing as what is this one? Longitudinal section of solid slab bridge. Okay, so use the mtext command. Mtext command. Just create the dialog box. Longitudinal section of solid slab. This is very small. You can use the scale command to increase the width. Yes, see. Okay, with this way only you can draft the solid slab. Okay, I'll show that pic. It is minimized now as of now.